All right, let's look at the homework 16.6, problem number 7. All right, so let's look at this parameterization here. All right, so first we want to find the equation of the tangent plane at u equals 2, v equals 0. All right, so let's do that. All right, so first we need to find the point. So we need to find the point. So let's call it x0, comma y0, comma z0. All right. So the way to do that, to get that, is just you just have to plug in the u value, which is 2, and the v value is 0, into this r function here. All right, so this is going to be, all right, so first component is u squared, so it's going to be 2 squared, it's 4. All right, and second component is 3 times 2 times sine of 0. Sine of 0 is 0, so this is going to be 0. All right, and the u is 2 times cosine of 0 is 1, so it's going to be 2. All right, so this is the point. All right, and number 2. And we need to find the normal vector. So let's call it A, comma B, comma C. Right? In order to find a normal vector, what we're going to do is we're going to find the vector R, partial derivative vector R with respect to U, cross product with partial derivative. Actually, let's see. We should probably plug the numbers in. No, let's do it without the plugging in yet. So you have that v. All right. So let's compute this. All right. So you have a vector I, vector j, vector k as usual. All right. So partial of this guy with respect to u. So you're gonna get 2u. And 3 sine of v, and then you have a cosine of v, right? Partial with respect to v, so that's going to be a constant, so 0. Partial with respect to v would be 3u cosine of v, and the partial of that would be u negative sine of v. Right? Then do the cross product. Let's see, first component is going to be 3 times, actually it's going to be negative 3 times u sine squared plus, right, actually it's going to be minus 3u cosine squared of v, right? And the mid one is it's going to be 0, and let's see, so 0 minus, it's going to be 2u squared sine of v, right? And the last one is 6u squared cosine of v. All right, so we got that. All right, then we just need to evaluate it at the given points. U is 2 and v is 0. So we evaluate this cross product at 2, 0. Right? So what you're going to get, right, u is equal to 2, but the v is 0. So first component is 0 here. And a negative 6, and the cosine of 0 is 1, so it's going to be negative 6. All right, this component, since v is 0, so it's 0. All right, here, u is 2, so, and the cosine of 0 is 1, and so 6 times 4, it's 24. All right. And if you want, you can actually pull out 6's in common. I will pull out the negative 6. right? So you can see that it's going to be 1, comma, 0, comma, let's see, 24 divided by -6 would be a -4, right? So we don't have to use -6, we just need the direction. So I'm going to take normal vector to be 1, comma, 0, comma, -4, right? So I'll probably, I should use the vector notation here, right? So we have that, right? And remember that once you have a normal vector and a point, and the equation is always, the equation of the tangent plane is going to be a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0, right? So in this case, a is 1 and x is 4, so you have x minus 4. And in this case, b is 0, that's gone. And the c is -4, so it's a -4. And the z minus z0 is 2, is equal to 0, right? So let's type this guy in. All right, so we got x minus 4 minus 4 z minus 2 is equal to 0. All right, so let's check the answer. All right, I came back and it looks like we got this equation correctly. All right, so let's go back and we want to find the surface and the tangent plane. All right, so let's try to figure out what kind of surface this is. All right, so here we have, looking at the original parameterization, you see that x is going to be equal to u squared. And let's see, y is equal to 3u sine of v, right? And the z is equal to u cosine of v, right? So what I'm going to do is I'm going to do this. This is going to be equal to, so I'm going to square both sides. So you have a y squared is equal to 9u squared sine squared of v, right? And then if you square this one, z squared is equal to u squared cosine squared of v, right? So what we can do here is actually, I want to combine this, but the 9 is in the y, so I'm going to divide through by 9. So we have y squared over 9, which is 3 squared, is equal to u squared sine squared of v, right? Then we can combine this. What if we add these two guys together? If you add them up, you get the y squared over 3 squared and the plus z squared is equal to u squared and the sine squared of v plus u squared cosine squared of v, right? We can pull out the u squared. Then you see that we have a sine squared of v plus cosine squared of v, which is going to be equal to 1. But remember that the u squared is actually x, so this is actually equal to x, right? So we have x is equal to y squared over 3 squared plus z squared, right? So we are getting, so this is an elliptic paraboloid, right? So let's try to see if we can sketch this using GeoGebra here. So I'm going to open up a GeoGebra, right? So let's sketch the surface. right? Surface is going to be, right, first component is u squared, right? That's easy to do. And the next one is 3u sine of v. Got that. And then we got the u cosine of v, right? Then u is going to go from, let's say, 0, actually, u is going to go from, let's see, we can just say 0 to 2 pi again. And if it doesn't look good, we can change it 0 to 2 pi. See what it looks like, all right? So you can see that we get this here, a fairly good picture. So we have a paraboloid, but it's an elliptic paraboloid, because if you look at it, so it's not a circular, it's elliptic. So it's an elliptic paraboloid. All right. Then we want to find the tangent plane at 4, 0, 2. So if you locate a point 4, 0, 2, which is going to be up here. All right. So you can see that here's a point right there. All right. Then the tangent line we found was, I'm going to just go ahead and sketch the tangent line, which was x minus 4 times z minus 2 equals 0. All right. So here, you can see that here, it's a tangent line here. It touches right at the point A there. All right. So it looks pretty good. All right, so hopefully we got enough information to answer this question. All right, so the top two doesn't look very promising. If you go down here, all right, so it looks like this is going to be the one. Let's see, is this the right point? So it's going to be right. So z value is around 2. And let's see, this is x value is around 4. And the y value is 0. So that's the point A that we saw right there here. All right. So looks pretty close. All right. So the picture is going to be that guy right there. All right. So let's go down and submit for testing. All right. I came back and it looks like we got this one correctly. All right. That's it. I hope that this was clear.